Alright, good day. So today we're going to be doing the container with most water problem on LeetCode. So let's just get right into the description of this problem here. So you're given an integer array height of length n. There are n vertical lines drawn such that the endpoints of the ith line are I0 and I height I. Find two lines that together with the height form a container such that the container contains the most water. Return the maximum amount of water a container can store. So if we just look at the example here, we'll see that the height of the the height of the value the index stores the height of the bar, so we can use that as our quote unquote the edge of our container. And in this first question here, we notice that even though this here is using 8 and 7, that's not strictly the that is not going to be the maximum amount of container water, like maximum amount of water that the container can hold, because that'd be 56. But because one of the bars are shorter than the next, we need to use the shortest bar to calculate that. Otherwise, water would overflow. So in this case, we see that the most can we hold is between these two at is index. Well, we don't really care about the index actually. It's just the amount of water that's held. So yeah, let's just get into it here. So our input would be a height, which would be an integer array of length n, and our output would be max water, which is an integer. So we want to calculate the max amount of water that can be calculate the max number of water that can. I had a stroke while I was writing this. So basically, you want to calculate the maximum amount of water that a container can store. A container is considered the area under two indexes with their height marked off by the value at the index. So the height of the bar is basically just the value stored at the index. So I didn't really come up with any cases really. They gave us a case here where there's only one, but given that the n is going to be always greater than 2, greater than or equal to 2, we know that we don't really have to account for if there's only 1, and this should work regardless of if there's more than 1. I mean, if there's only 2. So in terms of edge cases, not really anything too substantial to talk about there, so I just kind of left that blank. So let's get into the pseudocode. So we're going to use a two-pointer approach for this. Essentially what we're going to do is we're going to have one at the start and one at the end. The end is going to be the final index of the height array, and we're just going to close in until we find we're just going to compare the values until we find the max area or the max volume. So while the start and end are not the same, so since we're going to be converging at the middle, we don't want those indexes to look at the same value. So we don't want both indexes to be looking at, say, this value here, which would be index 0, 1, 2, 3, 4. So we don't want them to both be looking at index 4, because then that can give us a wrong calculation. So the max area is going to set this as -1. We know the max area because the values here can't be less than 0. We know that this here will be overwritten the first time around, so we don't really have anything to worry about with that. So while the start is less than the end, we set the minimum height as the minimum of the height at the start and the height at the end. And basically what that's going to do is that it's going to allow us to not overflow, quote unquote overflow, because if we were to just use the larger one, then it would overflow. So at the end now, we would start with the length of the container. So area is equal to the minimum height multiplied by the end minus the start, and that end minus the start would be the length of the container. So if the area, which would be the height, the minimum height here, multiplied by the length of the container, then we set that, and we compare that with the max area that we have stored, and then if it's larger than, then we set the max area as the area. Because we initialize max area as -1, we know for a fact that the first calculation that we're going to get is going to be so the max area in this first run is -1, and we can't have, this area can never be a negative value, so we know that it will be set. So if the height at the start is greater than the height at the end, then we want to increment. So basically this here is what's going to allow us to find those two highest bars, because as long as it's just going to increment until we find, So if the height of the start is greater than the height of the end, then we know we want to shift the end down because we know that we could probably find a bigger bar. So we shift that down, and then if the start one is smaller, then we want to shift it up until we find those biggest bars. And basically that's how we're going to go through, and that will recalculate the max area every time. When they're equal, it will end, it will break out of this loop and return the max area. So yeah, so if we just run it. So in terms of space, this should only, it's doing everything in place, so no extra structures really. And then in terms of time, we go through this loop here once, nothing nested, so it should take up it should always be O of n. So yeah, thank you.